In this class, we discuss the solution about two problems of complex number from previous year of IEEE. The first one from 2006 and second one from 2005. And the first problem is the value of summation I equal to 1 to 10 sine 2 k pi by 11 plus I cos 2 k pi by 11 is. Four options are given. From here we see that this is the type of 11th root of unity, but not the same as 11th root of unity. So we first discuss about the 11th root of unity. To find 11th root of unity, we have to find the solution of x to the power 11. This is equal to 1. This solution are 11th root of unity. And this is cos 0 plus I sin 0, right? And generalizing this value, we get this is cos 2 k pi plus I sin 2 k pi, where k belongs to z. This is the set of integer. And if we wish to replace k by minus k, we get cos 2 k pi minus I sin 2 k pi. Both are the same things, right? And x is given by cos 2 k pi plus I sin 2 k pi whole to the power 1 by 11, and it may be plus or it may be minus as we wish, as your problem. Now this is k equal to 0, 1, 2 to 10 must be, because the value of x, the number of value of x is 11. So we get the value of k from 0 to 10. These 11 values are the 11th root of unity. Now if we write this result by I square, this is minus I square sine 2 k pi by 11 plus I into cos 2 k pi by 11, and taking common I, we get I into cos 2 k pi by 11 minus I sine 2 k pi by 11. Okay, and taking summation I, we take common I from the summation, and this is cos 2 k pi by 11 minus I sin 2 k pi by 11, and take the summation I equal to, this is k equal to, this must be k equal to 0 to 10, but here k equal to 1 to 10. So we subtract from this result as this is cos 0 pi by 11 minus I sin 0 pi by 11. So this is 1, because if k equal to 0, if k equal to 0 put here, then we get this value is 1. So we add extra 1 term and we subtract here from this. Okay, so our result is I into summation cos 2 k pi by 11 minus I sin 2 k pi by 11. This is k equal to 0 to 10, and this is minus I. Now we have to find the value of this summation, and we know that if we using de Moivre's theorem, and we get this is cos 2 k pi by 11 plus minus I sin 2 k pi by 11. Okay, for k equal to 0, 1 to 10. And if we take, or if we write this result as this is to the power k, so we get this is alpha to the power 0, alpha to the power 1, alpha to the power 2, and 2 alpha to the power 10. These 11 results are here. Okay, now sum of this 11 result is alpha square alpha to the power 0 to alpha to the power 10. This is given by 1 minus alpha to the power 11 by 1 minus alpha. So this is 1 minus 1 by 1 minus alpha. This is equal to 0 because alpha be a root of x or alpha be a value of x. So alpha to the power 11, this is equal to 1. So this sum is 0 and this is same as this sum. Okay, because this value and this value are same if we take negative sign. So we get I into 0 minus I, this is equal to minus I. So the answer of the first problem is answer D. D is the correct answer. Now we go for the second one. This is very easy problem. Z1, Z2 are two non-zero complex number such that mod of Z1 plus Z2, this is equal to mod Z1 plus mod Z2. Then we have to find argument Z1 minus argument Z2, this is equal to, there are four given options. We let mod Z1 this is equal to R1 and mod Z2 this is equal to R2. And let argument Z1 this is equal to theta 1, argument Z2 this is equal to theta 2. And we have to find theta 1 minus theta 2. Right? Now since R1 and R2 are the modulus and theta 1 and theta 2 are the argument, so the complex number Z1 this is of the form R1 into cos theta 1 plus I sin theta 1, and the second is R2 into cos theta 2 plus I sin theta 2. Clear? And now mod of Z1 plus Z2, we know that this is equal to root under R1 square plus R2 square plus 2 R1 R2 cos theta 1 minus theta 2. Okay. Now this is equal to R1 plus R2 because it is given that this is equal to mod Z1 plus mod Z2, and we get this expression is equal to R1 plus R2, that is we get this expression equal to this. So we must have this value is equal to 0, and for what value of theta 1 minus theta 2 is 0, so we must have theta 1 minus theta 2 this is equal to 0 because cos of theta 1 minus theta 2 must be equal to, sorry, this is not 0, this is equal to 1. So we get R1 square plus R2 square plus 2 R1 R2, and this is the formula of R1 plus R2 whole square. Okay, so we must have this value is equal to 0. So argument Z1 minus argument Z2 this is equal to 0, and option D is correct option. Okay, but both answer are option D.